Good morning.
Good morning, Jim. How are you?
Good. Thanks for all your help. I really appreciate it.
Sure, no problem.
We'll just wait just a few more seconds. All right. 8 o'clock sharp. Probably a few more minutes and we'll go over some board announcements. Do you want to go over executive board updates?
Yeah, sure.
Yeah.
Yeah, they're pretty brief. Thank you, Jim. So yes, next month in March we'll be having in-person training in Alhambra in the Public Works Conference Room. So make sure to check the website and sign up for that. Again, it'll be in person. And then we are already planning for the June matrix, which is definitely going to have an inspection track. So it'll have a training geared towards inspectors, plan reviewers, and other code administrators. And that'll be coming in June as well. But other than that, Jim, I'll hand it back to you. Thank you again for having us.
Awesome. Thank you for all your help again. I appreciate it. Sure. Good morning, everybody. Today's topic is very interesting and very a part of our everyday inspections. I think about it a lot, and I wondered to myself a lot, how does this system actually work? You know, how particular do I need to be when I'm inspecting a fire stop system? I mean, I actually take it very serious. I'm very particular, and I follow the exact word instructions on the listing of the product. I like to look at pictures. If there's pictures available, I like to look at pictures and try to get the assembly to look exactly like the picture. I feel like sometimes, for a lack of words, I'm going to make it look like the picture. If you can get a fire stopping manufacturer to visit the site, I think that's the best case scenario always. And some manufacturers offer such support and often will even provide an engineering judgment on a penetration that it might not be your standard. It might be a combined penetration going through a couple different assemblies that really takes a look at. We really need to look at it a little closer and get a judgment on it. So without further ado, I'd like to introduce Brian and Sam from Hilti. Thanks for joining us today, Brian and Samantha. I appreciate it.
Yeah, good morning. Thank you, Jim. So I guess just to introduce ourselves to everyone on the call, my name is Brian Mereles Hall. I am the fire protection specialist for Hilti. That covers San Diego, Orange County, and Inland Empire. So while I may not cover your direct jurisdictions, there'll be times where Sam and I have to coordinate who will be, able to help out for a certain request. And Sam, if you want to go ahead and introduce yourself.
Yeah, so my name's Sam Hester. I am Brian's counterpart, so fire protection specialist. I cover LA, all throughout LA, downtown, even up through the valleys. So a lot of crossover, and there's a lot of different jurisdictions between the city of LA. So Brian and I, how we work with Hilti, and then how we also work with you guys is, Hilti is a construction sales company, and we have sales representatives that are covered by different trades. So we have a team for electrical, a team for mechanical, plumbing, interior finish, concrete, etc. And so we are a technical resource to them as well as you guys, because the same way, and I say this in my trainings with contractors, the same way that we are training our contractors, we want to train the inspection team as well, because we want you guys to have the same information to help streamline the process. So very much a resource to you guys as well, because we're really all here to educate and, really ensure, kind of to what you were saying earlier, fire stop is a listing approach. So making sure contractors have a listing that they're following. And I tell contractors in their training, the best way to take ownership of their inspection is to make sure that they have a listing and make sure that they're being very transparent with the fact that this is my assembly and this is what listing I used for that. And then in the case it's engineering judgment, we'll go through all of that. So if there's any opening questions, we can go ahead and answer. Otherwise, I'll share my screen and we can get started.
I think we're good. Thank you so much.
Yeah, thank you. Thank you for having us. Okay. Can everyone see my screen?
Yep.
Yes? Okay. Yep. So as we said before, we're going to be going through what we call Fire Stop 101, a life safety issue. So Brian and I will kind of bounce back off each other during this duration of the presentation. So our agenda today, so here we're going to talk about a couple of things, and starting off with consequences of building fires. We'll go through fire safe building construction and code requirements, go over testing and listings, secondary attributes of Fire Stop, then specifications, as well as additional considerations. So to start off with a question, try to get everybody engaged. How often do you think the fire department responds to a fire in the U.S.? If you had to think in minutes or seconds, how often do you think that is?
Seconds.
Seconds, about how many? Do you think it's 4 seconds? Do you think it's 45 seconds?
5 seconds.
5 seconds? Close-ish. It's every 24 seconds. So it's pretty insane to think about at this point, right? Every 24 seconds, there's a massive building fire that our emergency officials are being called into. That's over 25 billion in property damage loss, and then about the lives of 10 civilians per day. Where we would, just to keep this transparent, where I have to bring this home for contractor side, and even in the same degree for you guys as well. where this really has a massive impact, aside from the obvious, civilian deaths, is the property damage loss. Because if and when these fires occur, it's a lawsuit, it's a litigation, it's a lot of finger pointing of who did this, who installed it incorrectly, who inspected it even. We've seen, not in mine and Brian's history at Hilti, thankfully, but just throughout with colleagues that have been in the industry for a while, that when these things happen, they would try to bring everybody in with them. So, and I don't say that to scare anybody. I know with Fire Stop, it's very easy to get down rabbit holes, and this is why people think it's so confusing and very difficult. One of the reasons I've always found Fire Stop pretty interesting was the fact that it was overcomplicated, and realistically, everything is either a listing or it's not. And we'll go through our EJ process as well. Now, what is the leading cause of death in structure fires, if you had to guess?
Not sure about that one.
So the leading cause of death in structure fires is going to be the smoke and toxic gases. So all the smoke inhalation rather than the fire itself. So there's a lot of bullet points on here, and really a couple takeaways I want you to have is, over 75% of all fire deaths are caused by smoke inhalation. Smoke is very thick and travels incredibly fast. We like to say 120 to 420 feet per minute, about the length of a football field is how quickly this space is going to be engulfed in smoke within minutes. So the next bullet point will show almost 50% of survivors caught in a fire could not see more than 12 feet. Realistically, those who were in a fire, they can't see their, I don't know if you guys can see, they can't see their hand in front of them. So if you can't see your hand in front of you, do you think you could see a neon exit sign down the hallway? Likely not. So this, goes to show that just because, and the next point, almost 60% of people killed in fires are not in the room of the fire's origin. So there's, for some reason with fires, unless it happens to you, you're in a situation, you might not think about it, but you don't need to be in the room where the fire started in order for you to be impacted. And almost majority of the time, actually, almost 60% of the time, people that are going to be affected are nowhere near the fire. It's the smoke that's traveling through. So what we're trying to do with Fire Stop, we use buzzwords like containment and compartmentation. We're really trying to contain that smoke and fire to one space. So going into the next slide here, this is what we call a balanced approach to fire protection. So balanced meaning we cannot rely on one of these to keep people safe. This is very much a team effort when it comes to, buying people time essentially to get out the building. So at Hilti, and today we're going to be speaking on the containment piece. So how I describe this very simply is this is what's built into, our projects during the construction phase. To the naked eye, someone who doesn't know construction, they might not know what this is, but for us, people who, look at it, this is something we could easily recognize. Things that are more obvious to the naked eye would be our detection and our suppression. So our fire sprinklers, they're not triggered as they are, in the movies, perhaps. And it's not necessarily, that's not keeping anyone safe with the fire. Detection, the main issue we find with smoke detectors is, people aren't reacting right away. When I've given this training to contractors, I'll ask, what do you do when you hear a fire alarm? And some people say they get out of the building. Some people are honest and they say they either unplug it, take the batteries out, or they do nothing. And I think depending on, where we've been in our lives, we're somewhat conditioned to think if we hear an alarm, we want to look around to get validation from others to see, oh, is it a fire? Or we're thinking, I don't see a fire. I don't smell a fire. It can't possibly be this building. So that really is the honest truth why we cannot rely on detection, just because people aren't reacting to them. So the containment is, the idea is, whether it's a 1 or 4 hour condition with a system following, if people aren't reacting right away, they have at least that allotted time, depending on the assembly, to get out of the building. So I'll go through some examples. So this example is, we have some other ones just in different presentations where we talk about, all the implications of building fires. And in the past, it's between typically the 70s and 80s where we saw a lot of major building fires. And I say the silver lining in that is it really had the building code take a step back and say, this is not okay. How can we, make this attribute safer, I would say construction as a whole, and you guys could probably agree, has come a really long way since certainly the 70s of, how we approach safety. So this is right in our hometown, First Interstate and Bank of LA. So the automatic sprinkler system was drained and the building fire pumps were shut off at the time of fire. So realistically, this fire spread more than it really could have because of the sprinkler requirements at the time. So bullet point, that's third down. Visitors in the observatory on the 99th floor were asked to evacuate, but they could only manage to get down to the 70th floor due to smoke rising through the stairwell. And then fire protection systems in place, and the firefighters were able to extinguish the fire. The consequences were, oh wait, sorry, it went to the other one. Vertical spread was also through poke through and pipe recesses in utility shafts. So the lack of fire stopping between the floor slabs permitted the fire to spread from floor to floor throughout the space. So this, this really is, in a couple of slides, we'll go over all the attributes of fire stop. It's not just, penetrations or joints. We have edge of slab as well. So this is all one cohesive system that has to work together. Now going into John Hancock Building in Chicago. So I used to live in Chicago in my previous Hilti life. I covered the electrical trade out there, and I do remember when this happened, and this was caused by a candle left in an apartment on the 50th floor. So I think another misconception with these major building fires is a lot of times it's something very small that is starting this fire, and fire, it's the smoke and fire, it's going to grow. Once it'll catch on to something, there's really no putting it out. So the alarm system failed during the fire. So that's showing an attribute of, our balance of fire protection. If we were just relying on the alarm system, this could have been a lot more catastrophic for everyone in the building. So fire protection systems in place, and firefighters were able to extinguish the fire. The consequences were not as bad as they could have been, but still, we're really the best thing with this is detecting it early if these fires happen, so we have enough time for the team to respond. This is a more recent example that is more recent and I would say deadly compared to the two before. So Grenfell Tower, this is an apartment building in London, England, that was originally built in the 70s, and they renovated it in 2015, 2016 time. And this is still known as one of the most deadly building fires in the last 30 years. So this killed 80 people. And if you could see on the picture, so this started from a fourth floor electrical short. And when they were treating this building or renovating it, it was all new HVAC and the edge of slab. So the contractor that was treating the edge of slab or didn't treat the edge of slab, didn't treat it properly, they were at fault for this, because as you could see, the fire jumps all the way up the building coming from the fourth floor. This is really frustrating to see for me and Brian, and maybe I would hope for you guys too, just as someone who works with fire protection every day, because at this point in time, we have all the resources and technology and systems to where this is preventable. Where in some cases I give grace to fires that happened in the 70s and 80s. While it's horrible, we simply just didn't have the same information that we do today. So this is something that's 100% preventable. And like I said, this killed 80 people. So absolute worst case scenario when it comes to the building fires.
Can I throw something in really quick on that?
Yes, please.
The older buildings that we convert are very hard to convert to the fire stopping of today.
Yes.
We have a couple older hotels that have been converted recently, and the amount of money alone that it costs to take things apart and fire stop to the point where it does meet that condition is very expensive. And the contractors and owners are always trying to find ways to minimize what they do. And it's hard for the inspection team to go peel it back far enough to say, yeah, we've got it all. So building like that is probably the same thing. It's so hard to peel it back to the point where you can really fire stop completely. And if you leave anything undone, or if you give any leniency, that's the easiest, quickest path for the fire or smoke to go. So it's important to dot the i's, cross the t's, I guess.
Yeah, no, yeah, definitely. And when we're working with contracts, and especially, if I'm supporting contractors throughout, the city, even Long Beach Airport was an example of this too. Contractors, when they're going through buildings that are renovations, especially older buildings, they're almost nervous to go in to touch certain things because they know as soon as if they touch it, if they open anything up, then they have the whole scope of it. And it very much is like a can of worms situation, and it adds in time, money, labor, and it's from our perspective, at least with our engineers back in Texas too, because they get looped in a lot. How are we going to get this condition that was, this building was originally built in 1911. It's not a normal deck or not a normal wall, concrete wall that they have. So how are we going to bring this back up to standard? So yeah, it's very much a challenge that, we see, we know you guys are seeing. So we hope that, hopefully with this too, and as we can start, a working relationship together, we can, come to better understanding of how can we get this streamlined and easier for everyone that's involved.
That'd be great. Thank you.
Yeah. Yes. So I mentioned before, one globally applied principle for fire safety is going to be compartmentation. So our goal here is to, and you see these pictures, we're trying to compartmentalize the smoke and fire to one space. So the spread of fire is restricted by dividing this building into separate compartments. When we're designing our buildings, depending on building type and, model occupancy type, building code's going to state, these are your fire rated floors, these are your fire rated walls. As you guys probably go through different types of buildings, it is different, depending on what building you're at. Any type of healthcare job is going to have a lot of F ratings, a lot of L ratings, which we'll talk about too. Some commercial buildings, it might just be more smoke and sound ratings. I want to highlight that point too, because sometimes it's thought of just if something's not fire rated, then it's not treated with the same, I guess, intensity as it should be if it was fire, because as we said before, smoke is what's killing people during these fires. So even if something is smoke rating and not rated for flame, it should still be treated with the same level of importance because we're trying to block off that space. So as you see on the right, you have everything sectioned off for your fire rated floors. And then for your fire rated walls, let's just say this is, an apartment building. If you see something that's sticking out here is that all the fire rated walls, it's just leading people out to a path of egress. So typically with our fire rated walls, that's what we're going to see. Now, this is a real life photo from New York City in 2014. This is, I would say, best case scenario when it comes to fire stop, because it's a reality of the world we live in. There's fires that are going to happen, and it's more how we react to them and how we're going to prevent them rather than keeping it or letting it spread throughout the building. So this is in New York City 2014, and as you can see, the smoke is just fully ablaze in one space. It's a horrific incident for that one unit, but it's not spreading throughout the rest of the building, which is, for us, best case scenario. So other people aren't getting hurt. Maybe some damage throughout the building, just from experience I've had with buildings where there's fire. There's going to be some issues that might go throughout the building, but I feel really weird saying only one casualty due to smoke inhalation, but one casualty due to 80 compared to 400. It's a little bit of a better number, really highlighting this could have been a lot worse. This was started with an overloaded power strip in the apartment on the 20th floor. So here are all the areas that allow for, fire and smoke spreads. So these are all the areas where Brian and I, if we're supporting job sites, all the areas that we're looking at, while, trades are only focused on, specific areas of it. So our unsealed open joints, our pipe penetrations and ducts, cable penetrations, doors, gaps at the edge of slab, and then your membrane one-sided penetrations. Now going into building construction and code requirements. So fire stopping is not new, as we all know this. It's required by all current and legacy codes, and in the great state of California, we get more eyes on it. It's taken, I'm throwing out my old market a couple of times. It's I've worked in a couple of markets, I guess now with Hilti, and it's definitely one of the hardest jurisdictions out is in the state of California. That's something that we all knew of back east as well. So I appreciate it just because obviously this is very important, and it's really reiterating what Brian and I do every day. So I feel like we have a really good direct, maybe indirect way of supporting each other when it comes to projects that we're on. So if you're ever reading up on the building code as we do, and as we likely have to reference time to time, fire stop's going to be in section 7, and you're going to see the through penetrations for walls, floors, membranes, joints, exterior curtain wall, and then also for special inspections. And then you'll see over on the right hand side the reference test standards. So I highlight this in terms of Hilti, where we have over 1,600 UL systems that are published. Everything that's published is through our testing team. So our team of fire stop engineers and our testing team, they're down in Irving, Texas. That's where our lab is. And we are a UL approved facility, meaning that UL doesn't have to fly out to watch our burn test anymore. We can do them all in-house and submit our own information to them. So that's been very helpful, for our business in the way that we support our contractors, because, we're able just to give them systems as, basically we come up with them, UL has to just put their stamp on it, and then it's good to be used from that point. So everything is all, it's pretty standardized for these reasons. The key language with fire stop requirements is the keyword is systems. And this is something that our contractors, they get tripped up on all the time. So, and I remind them it's not Hilti saying it's just Hilti, you have to use Hilti products, but it's coming right from the building code, whether it's us, whether it's another fire stop manufacturer, everything is through an approved fire stop system. So whether it's through penetration fire stop systems or fire resistant joint systems, following their reference test standards. So to put simply, with what we're trying to achieve with fire protection, you have two dissimilar materials, and we're trying to restore that rating with fire stop. So, if you have one layer of drywall, UL says that's a, 1 hour wall, 1 layer, 2 hours for 2 layers. The second there's a hole punched in that wall because contractor has to run a conduit through, it's no longer a 1 or 2 hour wall. So we have to restore that rating with fire stop. It's the same idea with joints, two dissimilar materials meeting. How are we bringing that rating back up? So for through penetrations, joints, and membranes, we're sealing that opening to bring that rating back up to what it was. Now going into fire stop system and listings. This is a trick question. I'll preface with that. What is the hourly rating of a fire stop product? I kind of gave it away before. So just the product by itself. Does anyone have any guesses? It's 0. So the product itself doesn't carry any type of rating. It all goes back to the system. That's the first default that you should go back to. So as many products as we make, as great as they all are, they essentially mean nothing if they're not being applied properly, right? Because it's just going to show everything has to go back to the system that was tested and approved. An easy example I'll give for this is if you see that silver tube towards the bottom, that's our fire caulking. We make essentially two types. We have FS1 Max, which is shown here, which is an intumescent. So this is what's going to expand when it's exposed to heat and close off that opening. So this is used in all penetrations. So think of a plastic pipe that's melted away within 2 minutes. The intumescent from that point is triggered once it's exposed to heat, and it's going to expand and close off that opening so no smoke is traveling through. We also make another product, comes in the same packaging. It's silver. It also is red when it disperses. It's called CP606, and this is an acrylic-based sealant that is used at the joints. It's used to accommodate movement, so this is why it's used at the joints. Contractors on a job, we're all simple people, right? If they see something that looks like the product they use without actually looking into it, they might go ahead and use it, and it's not rated for that. 606 isn't rated for any plastic pipe or any insulated pipe. We do have listings for metal pipe, but just to put this example to you, it's all reliant on the system that has been tested. There are many factors affecting fire performance, and each are parameters for the testing of a system. So for through penetrations and joints, these are, if I'm ever being asked, how, like I need a listing, or if I'm trying to work with a contractor on, do you have an assembly for XYZ? Through penetrations, we're looking at the size and type of the penetrating item, the size and type of the opening. This is for, your annular space, trying to give contractors parameters. So, if they have a 2-inch pipe, they're not putting a 15-inch hole through the wall just because there's not a system to support that, but that's also way more material and labor for them to seal off that opening. And from a fire protection standpoint, it's not the most reliable. Your desired fire rating, so that's going to come right from the plans, and then your floor or wall construction type and thickness. So, is it a concrete floor, concrete over metal deck? Is it a concrete wall? Is it drywall? All of these attributes matter, of course, just because of how, how these are, put in our burn assembly. And then, of course, your fire stop systems to be used. For joints, we're always going to look at, what's your joint width, the desired assembly rating, floor, wall construction type, any movement requirements, stud width for gypsum walls, and then the fire stop products to be used. So when Brian and I are working with either contractors or you guys, if we're asked for systems, it's okay. If it's a penetration, what is the penetrating item? Because for penetrations, there's a lot more. There's metallics, there's plastics, there's insulated, there's cables. It could be all of the above. It could be ducts. So what is it exactly? What size is it? What size is the opening? And with joint, typically the main thing I'll ask is what's the joint width, aside from, what are the two areas that are adjoining together? So once a fire stopped or tested system has achieved the desired fire ratings from our lab, that point it's, like I said, it's sent off to UL and then later published.
Sam, I don't think you shared with sound.
How do I do that?
There, I can, when you go to share, just hit the include sound on the share content. Yeah, so stop sharing and then reshare.
Oh, share with include sound. Thank you. Okay, we're back.
CUL and ASTM standards. There are 2 furnaces in this facility. The one on the left is used to test floor or ceiling applications, while the one to the right is for wall applications. The testing process begins in our prep area. In this example, the assemblies consist of plastic, insulated and non-insulated pipe penetrations. Hilti fire stop solutions like FS1 Max and fire stop collars are installed around the pipes. Once the assemblies are built, we add thermocouples to measure heat transfer through the assembly and the pipes as required by the testing standards. As final touches are put on the assembly, technicians prepare the furnace and afterburner. The afterburner is a high-powered incinerator that burns the smoke and gases generated by the test itself. When it's ready, the assembly is carefully secured to the furnace. Lead wires from the thermocouples are attached to the monitoring system and tracked with our computer program. With a mouse click, the furnace's burners are ignited and the test begins. Within a few minutes, the PVC pipes and insulation on the fire side of the wall melt away, causing them to ventilate smoke into the room. Heat causes graphite in the products to expand, creating a seal that continuously expands as long as the heat is applied. This closes the pipes and limits the passage of smoke and harmful gases into other parts of a building. After 10 minutes, the temperature in the furnace is 1300 degrees Fahrenheit. The burn test can last anywhere between 1 and 4 hours, depending on the assembly being tested. As the last few seconds tick away in this 1-hour test, the temperature in the furnace is 1700 degrees. Our products have done their job to protect the penetrations and to keep the fire on one side of the wall. As you can see, there's not much left of the pipes exposed to the fire. The fire side of the assembly will now be subjected to a powerful stream of water. We use an authentic fire service hose and nozzle during the test. Distance from the wall, water pressure, and spray duration are all dictated by ASTM and UL test standards. As the water hits the superheated sheetrock, it practically explodes from thermal shock and impact of the water. This type of test helps determine structural integrity of the fire stop systems. As the charred wall disintegrates, most of the assemblies and leftover pipe go with it. But on the non-fire side, the assemblies remain in place exactly as designed.
All right, so hopefully you all were able to see something that maybe you hadn't considered that goes into the fire stop testing. I know most people don't ever get a chance to see an actual fire stop test, so that's why we like to share it in these presentations so you all can see what goes on during it. So when it comes to fire stop, these are really the two main ratings that are going to be looked at more and more often, right? Obviously, our F rating is the one that we are most familiar with, our fire rating, somewhere from 1 to 4 hours. But another big one that's coming up in construction right now is the T rating. So if you don't know what a T rating is, think of it like if you had a 2-story building with a penetration, excuse me, from the first floor to the second floor. You know, even if the fire wasn't able to spread to that second floor, due to the actual heat during the fire, the pipe can heat up the second floor so much that then we can actually get a fire started on that second floor with combustion. Why is the T rating becoming more and more of a big deal? Because as construction switches from organic materials to inorganic and synthetic materials that have lower combustion points, this is a point of emphasis. So especially on projects like healthcare projects, schools, large dorms, this is a point of emphasis that we've been seeing lately. If you wouldn't mind going to the next slide, Sam. So I don't know if anybody picked it up in the video, but just how quickly the PVC and then even the fiberglass insulation melted. So if you caught it in the first 10 minutes in our furnace, the temperature is actually 1400 degrees. So that means within the first 10 minutes, all of these material types are actually going to melt. And that's why, especially on penetrations, we're going to need extra fire stop, a different type of fire stop material. And that's why it's going to be the intumescent base, like how Sam pointed out with the FS1. While we do have listings with 606, it is typically to metallic penetrations, because with metallic penetrations, we're not worried about that penetrant melting and creating a larger opening. All right. So with that, like we're really trying to hammer home this point, when it comes to fire stop, right, we should have a system for each and every condition, every application, right? So again, our fire stop system is going to call out the rated assemblies that we're trying to restore the rating in. And then in this case, highlighting a through penetration condition, again, you're going to have your size and type, and then what product or material is needed, as well as, our limitations in terms of opening, annular space. And then we're going to actually have a tested number, which is, we'll go over what it's based on here. So this is actually UL's nomenclature system. If you've never seen this, UL actually has this published for through penetrations as well as joints of how they actually name their systems. This is a really easy way, if you get familiar with this, to do a really quick check of the systems that are being provided to you to make sure they're correct. So the system that we have highlighted here is WL1054. This is probably the most common used fire stop system, at least from Hilti, that's used on a project, because this is for bare metallic penetrance through gyp walls. Even if I didn't know that that was the exact system number, if I was familiar with this nomenclature, I could figure out what type of fire stop system this is. Why? Because W stands for a wall penetration. L, that second letter, means it's a framed wall, a gyp wall. And then the UL system starts with the number 1. So a 1000 series is metal pipe, conduit, or tubing. So if I was walking in condition with the customer and it's a gyp wall, a bare metallic penetrant, and they give me a system that's an F, that starts with an F on it, then I immediately know it's incorrect because that's for floors, right? So that's a really quick way for you to be able to help possibly save some time, right? Or if we're looking at metal pipe penetrations and your custom and that contractor gives you a WL, okay, we're good. It's a wall, it's a gyp wall, but it's a 2000 series. That's for non-metallic for plastics. Again, immediately I know it's incorrect, and they're not installing the right system. And then we also have membrane penetrations, and the biggest place where we're going to see that is going to be with our electrical boxes, right? So membrane penetration just means it's only creating an opening in one side of the assembly. So we're thinking our typical gypsum drywall walls, then it's not going through both sides of that assembly. It's only going through one, right? So typically from our CLIV, which is the system for those putty pads, once you get into more than 100 square inches of openings within 100 square feet, then you're going to need to have a rated box, now a rated putty pad around there, right? And they need to be separated by a minimum of 24 inches. There are some parts of the CLIV that will allow for back-to-back boxes in very certain conditions with very certain sizes, but again, the limitations are expressly called out in the CLIV.
I got a quick question on the putty pads.
Yes.
I get questions a lot on, hey, can I put these together? Because it seems to me when people try to stretch them on the box, it seems like they have memory and they kind of pull back to their original size. Can you cut strips and kind of add to them? And can I put a bunch of them together
that's
and put them on a sub panel? Or
that's actually our recommendation is customers should be purchasing larger putty pads in order to avoid that stretching for 2 reasons. To your point, if you stretch a putty pad, first and foremost, the CLIV calls out a 1/8 thickness on the putty pads. Guess what thickness they come out in the box? They're at 1/8. Yep. So if you're stretching it, you're already non-compliant because that material is thinner than what's called out in the system.
Okay.
Number 2, if you do that, the material itself actually loses its tackiness or its stickiness. And then I'll get a call saying, hey, Brian, my putty pads are melting off my boxes, or they're slipping off my boxes. What's going on? So yeah, they can and they should be using larger putty pads, cutting away any excess, and then you can actually essentially pinch those seams kind of like puff pastry in order to create other ones or to go around your conduit as called out per the system.
Can you add them together and maybe put them on a sub panel?
Yeah, so we do actually have a system, WL7277, that will allow putty pads to be used on an electrical panel.
Okay.
Yep. So it's just quilting on the back of them is how that works.
And it gives you some kind of direction on overlap or pinching or.
Yep,
Yeah,
exactly.
yeah.
Yep. So the system will give them the instructions on how to install that.
That's awesome. Thank you.
Yeah.
Yep. So when it comes to fire stop, these are going to be the most common types of penetrants, right? So our non-combustible items, we're not worried about melting. Our metallic penetrants, our combustible items, stuff like insulation, plastic, cable bundles, and then our large openings, right? So maybe you have a block out, multiple types of penetrants, or it has a duct or a cable tray, or it was a blockout that was supposed to be multiple, but now we only have 1 or 2 penetrants, so we have very large angular space. For all of these conditions, we will have some system. But like Sam talked about, even though we have close to 2,000 published systems, it doesn't mean that we have one for every single scenario. All right, next, please, Sam. So when we're talking about joints, these are the most common types of applications for joints, whether it's your head of wall for your metal deck joints, right, where you're typically going to see either castle cuts or spray, like shown in the picture there. Top and bottom of wall for your flat deck concrete or for your wood framed, possibly floors. And then you're going to have stuff like wall to wall and edge of slab. We have, a couple other not as common conditions like floor to wall and items like that, but these are going to be your most common. And again, no matter what type you have, we have the appropriate systems. One thing I do want to call out here, and maybe it's something for all of the inspectors in the training to think about, is how often are we inspecting bottom of wall fire stopping? Now, the reason I ask this is because something that we've actually seen in the Southern California market is a lot of contractors are not installing bottom of wall fire stop. A lot of inspectors are not inspecting it because a lot of people don't think about it. It's being covered up by the baseboard or some other finishing. So it gets forgotten about. However, that is an incorrect install. And that is a area where the rating of the assembly has not been restored. There is a joint at the bottom of wall. If we are not treating it, that room has a weak point. And a lot of people think, oh, well, it's not that important. It's the bottom of wall. If a fire happens, heat and smoke rise, right? That's where they're worried about. But per the code, there needs to be full continuity from the floor all the way to that ceiling assembly. If any portion of that is not being restored to the rating of those assemblies, that room is not a rated room. And bottom of wall fire stop is an area that we consistently see that is being missed. So we just wanted to point it out, and maybe something for, the inspectors here just to go over in your mind and make sure you're actually taking a look at it.
That's a great point. Thank you.
Right. And then we'll also have perimeter fire barrier, edge of slab, curtain wall, right? There's a lot of different names and verbiages we can use for it, but this is the number one reason why we actually see engineering judgments or EJs requested. And I think our next slide will show us a little bit why. So edge of slab has the most components to it, right? So a lot of times when Sam and I talk about a fire stop system, we point out to customers, contractors, hey, this is really paint by numbers, right? You're matching up the number on the system with what you're seeing in the field, and you're making sure that each point matches. And that's how you know you have the correct system for you. When it comes to edge of slab, there's a lot of different numbers, right? If we're looking at that paint by number analogy, instead of having 4 or 5 different components, we may have that system call out 10, 15, 20 different components, right? Because it is such a complicated area. So that's why you'll see the most engineering judgments. We have a few staple systems, and really that's just to give us the testing to be able to now support those different engineering judgments, because the spacing, the joint, the parameters of each edge slab system, they're just so numerous that there's no way to have the amount of systems listed for every single condition we're going to see out in the field. Okay. So again, we talked about that paint by number kind of idea when it comes to fire stop. You can see from that diagram just how many numbers, right, there would be to look at. So again, that's why we'll have some of these systems, a few ones, and hopefully that works. But for the most part, when it comes to edge of slab, you're going to see an EJ. So we've thrown that phrase out a few times, Sam and myself. So what is an engineering judgment. So this is actually coming from IFC, right? And they're giving a breakdown of what it is. First and foremost, an EJ is not to be used in place of a system. Why is that? Even though an EJ is us taking the testing from other systems that have passed, that EJ has never been in the furnace, right? So while with Hilti, it is a extremely educated guess that we're taking, it is ultimately still an educated guess because it has not been put into a furnace and tested in that exact in the exact condition application that we are providing the EJ for. So we always want to have a system when possible, right? So each manufacturing company is going to have their qualified technical personnel write those. So in our case, our FPEs, our fire protection engineers, are going to be the ones writing those EJs and providing them. And engineering judgments are also contractor and site specific. So even if the contractor had the same condition on a separate job, they need to request a new engineering judgment for the current project that they're on. Or maybe as the inspector, hey, we got this EJ on this project, but it's for this customer. Now we're on a separate project. It's a new customer. We want to make sure we have that EJ being resubmitted for that project. That's something else that's very common that we see. I know a lot of areas have real hesitation when it comes to engineering judgments because the reality is there are some manufacturers out there that will provide engineering judgments with a bunch of performance notes. And we've seen some ones where even Sam and I have gotten our hands on some of these engineering judgments and say, oh, we know Hilti would never support that, right? When you talk to different inspectors, to different contractors, Hilti is known as being more conservative when it comes to what we will put on an engineering judgment and support, and that's because we're really making sure that we are 100% confident that this would pass if it was actually put into a furnace. And we're actually a part of UL's accreditation process. So they actually do an audit of our EJs. So they will actually take our engineering judgments and put them into a furnace. Last year was the first year we were part of that, and we had a 100% pass rate. So that's, again, one of just highlighting how seriously we take those. So what are some things to look out for, right? A lot of times when we do these trainings for inspectors, hey, give me a couple key things that I can look out for. You have a million and one things that you're trying to pass. When it comes to fire stop, where the big mistakes come from. So when it comes to penetrations, the number one thing that people get wrong is the annular space, right? So that kind of dead space between your penetrant and your opening. That is the number one reason people get through penetration fire stop wrong, or you have to fail them during inspection. The number two reason is cable bundle fill rate. So if a customer is not using a preformed fire stop device, if they're just caulking a typical sealant that we're all used to seeing, our systems will call out anywhere from 33 to 45% fill rate, right? So if you have a 2-inch conduit, you can't fill it 100% and just use FS1 in there. The system does not support that. And then lastly, oversized plastic pipes without collars or some sort of additional fire stopping. So when it comes to plastics, anytime you get over 2 inches, just using a fire stop sealant is no longer sufficient. We need to add extra protection there. For joints, the joint size is too large or does not match. You may get incorrect depth of fill, right? So if it's saying a minimum half-inch, a minimum 5/8, a lot of times we'll see that they have less product than what's being called out inside of the opening. And then for times where you need mineral wool, incorrect mineral orientation, right? And that's an issue because we're going to be worried about that actually falling out of the opening or the joint.
So one of the ones that I usually see is the bundling of low voltage cables through penetrations, and it's usually anywhere from 5 to 30 cables going through a penetration, and it's just fire cocked. To me, it seems like it should have some kind of collar that we just expand and close that opening off like you kind of showed in your demonstration.
Yeah, exactly right. You got to make sure you have a system. And for the most part, if you're having that many cables, you would have to have a really large opening. And most of those systems that are just for sealant only aren't going to allow an opening that size, right? So we're making sure we're following the system in its entirety. So that's a really good point. So we're gonna actually go through some actual pictures that we've seen. Maybe some of you have seen similar items on job sites, right? So these are examples of the poor install, right? So on the left, number one, you can't have scab patching. Maybe for whatever reason the annular space didn't work, so they asked the drywaller to just put a little piece of drywall in there. If you look closely, even if for whatever reason that was the correct method, there's still visible gaps, right? So even then, it's not completely done. Another common one is, maybe a customer's in a hard to reach place. Maybe they were on top of a lift when they were trying to fire stop around these MC cables, right, that we see on the right. Well, that's not connected. That's not fully fire stopped. So immediately that's incorrect, right? And hopefully that's obvious as to why. But again, these are pictures from actual conditions in the field that we're seeing. And we got a few more examples here.
On that really quick, on that one that wasn't all the way around the penetration, would that expand and still maybe work, or is it just completely not going to work? That's what I'm kind of saying. Do I need to be more, or can I give a little bit and say, you know what, that stuff is so good that it's going to drip and close? And
I would say even if hypothetically it is going to expand enough, we have issues with tooling here, but it should be fully surrounded and closing, right? No matter what, that's going to be a weak point.
Thank you.
So here are a couple examples of those cables, the conduit that we talked about. So on the left-hand side, you can't just stick whatever material inside of there to fill that opening. They probably went to their local supply house or Home Depot, got whatever foam they had and filled that, right? I always tell people that foam is probably more flammable than the cables themselves, and that's going to present an issue, right? And then beyond that, if you look really close, there's still some gaps and voids where the conduit's actually going through the wall. And they didn't properly tool it. A lot of times I know as inspectors, if we see something that looks this ugly, we're just going to fail it there, right? Because we can just see that it's already bad workmanship and there's likely going to be issues, and there are here. And then on the right, that's kind of what I was talking about with overfilling those conduits with cables. Again, a system like that just uses sealant is going to call out 33 to 45% fill rate. We're at much higher than that. And like we saw in that burn test, as those materials burn away, we don't have enough product now to close that up. So even if it was, FS1 instead of that white caulking, there isn't enough fire stop there to properly seal that opening. All right, let's go to the next ones. So on our large openings, right, our mixed penetrance large openings, on the left, that's really clean mineral wool install. That looks great, but there's no fire stop. Right? Mineral wool alone, there is no listing for that. The one on the right, if you've ever seen our blocks being used, they're sometimes referred to as pillows. They're actually supposed to be oriented like a brick wall, right? That's to have the right friction and to make sure as pressure changes in a fire or that fire hose stream test that we saw in the video earlier, that it has enough friction to hold it. As it's oriented right now, those blocks will likely fall out. And then on the joint side, right? So on the left, there's a visible gap here, and there's a couple issues here. They probably didn't follow our instructions for use and properly clean that opening, so they had issues with adhesion. And then if you can see the fire stop there, if you look closely, you can see how thin that fire stop actually looks. So they probably didn't even put the correct depth to fill. So as that material cured and shrank a little bit, because it's water-based, it actually pulled away from the assembly and fell out of the opening. And now we have a visible joint again, right? Or a visible gap in our joint. And then on the right, a very common phenomenon known as lip sticking, especially seen at the bottom of wall, but sometimes wall-to-wall orientations. Like if you had a gyp wall meeting a concrete wall, a contractor will run a small bead of caulking along that joint, run over it with their finger or something else, and now they think just because there's red there, it's sufficiently fire stop, but it's not following any system. Top of wall, hopefully we can all tell what's wrong with the photo out there on the left, right? With obvious gaps. It's just applied very poorly. We should be making sure our fire stop looks like the example on the right. Again, on the left, ugly install. The issue here is you don't have your, even let's say if it looked very clean, they don't have the proper 1/2 inch overlap onto all portions of the assembly, as shown with the one on the right. Another point that I want to point out with the right is just because that's not red doesn't mean that's incorrect. The products which can be chosen maybe for product availability or even aesthetics, right? A lot of times in a concrete area, we're going to want to use our gray version instead of our red for aesthetics. So just something to point out as well. Just because it's white doesn't mean it's acoustical. We have fire rated products that are white as well. Here's some more examples that inspectors have asked me for on job sites, right? Especially as this piece with documentation comes up more and more. So that is not a Hilti requirement. That's going to be a spec that's called out by owners or jurisdictions or maybe GCs. We need to have a sticker or something that calls out what each fire stop product is. So that 2-hour rated large sticker in the bottom middle, right? That's coming from the code where you have to call that out. But then those smaller identification stickers are not, but they are becoming more and more common. When it comes to time to inspection, right, it makes it easy because it calls out what system or engineering judgment was used, what product was used, who installed it, on what date. So it can help with the inspection process, but again, it's not a requirement as of yet.
Yeah, so I'll go ahead and take this back over. So going into secondary attributes of fire stop. So what does that mean exactly? So the fire stop products that we're using, there's additional benefits, for them, right? So our the main thing is going to be our airtightness. So, we're trying to prevent smoke from traveling through the building, right? But we need these spaces to be closed off with airtightness. Movement, we're going to see this more with top of wall and edge of slab, and if anything, actually now movement is starting to come for penetrations. Water resistance, which I'll talk about more in a bit. The main thing that we'll get from this is mold, or one of the issues is mold. So I will say all of Hilti's testing with our products, there's not going to be any kind of mold that's going to grow. So that's it's kind of a good thing on us that we found out in the last couple of years. The other thing's going to be STC rating, so sound. So, hotel, apartment building, even office building, you don't want to hear the other people around you. Any medical healthcare buildings, there's laws in place to where it's not supposed to be really public information. So this optional test that we do for the W rating, it determines the effectiveness of a fire stop system to restrict the flow of water. So you see here, this is from our lab. These two water columns, they're about 3 feet, and they're filled with water for about 72 hours. And if there's any drips of water that flow through the bottom, then it fails. So we're really just, testing this to, restrict the flow of water. We have these, we call them cans. They're fire stop devices. So instead of an MEP contractor using a metal sleeve in the deck and then coming back and fire stopping it after, we have our sleeve that has fire stop already built into it. This is a product that has been approved for a W rating, as well as our FS1 Max. It'll have the W rating on the product data sheet, but we also have written letters saying that it will impede the passage of water. So again, here just highlighting, the attributes that come in with our sealants. So smoke penetration, I talked about, sound transmission. Other one I didn't majorly highlight on with air leakage is, the moisture damage, hot and cold spots. The big one's going to be disease transmission. So we'll see this obviously mainly with our healthcare buildings, and this will lead us to my next point of L rating. So this is another optional test per UL 1479, required on all smoke barriers. So we're going to see these in healthcare and in prisons. Really, these are facilities that have to have defend in place strategies. So L rating, we're determining the suitability to restrict the passage of smoke. A smoke barrier, I'll read the definition. Simply, I like to think a smoke barrier of just like a smoke chamber. So a continuous membrane, either vertical, horizontal, such as a floor, wall, or ceiling assembly that is designed and constructed to restrict the movement of smoke. So we're measuring the amount of air leakage through the fire stop system. So where this is obviously smoke passage is very important in any type of project. When you think of any healthcare projects, where there's bed towers and prisons alike, these are facilities where I said defend in place. So if a fire were to break out, you have people connected to beds and machines. In a hospital, you can't exactly get them all out of the building, right? It's a similar idea with prisons. So this is just this test is putting into place that there's not going to be any type of smoke passage going through one space to the other. Additionally, so our dynamic movement for top of wall joints. So our movement capabilities, we're going to have our percentage of compression or extension. So this is just indicating, how much, what's the percentage of compression that, is permitted for the maximum joint width. So these are going to be called out on all of our systems. And this just, it depends on, kind of what the job requirement is. This is a table that we like to share for mineral wool compression. So the required mineral wool width. So you'll see on the right or on the left tab, you'll have your joint width. So let's say you have a 2-inch joint width and it has to be 33% compressed per the plan. So this would have you at a 3, right? So this is just a table that we can share this with you guys as well. We've shared it before, either with other inspectors or even with like drywall contractors or self-performing general contractors who are taking in this scope of work so they can better understand. So this is something we can share with you guys as well. I don't expect everyone to be the human calculator because I know I'm not. Now going into specifying fire stop systems. So here in the specification division, so fire stop's always going to be in Division 7, but here are all the other areas for, Division 21, fire suppression, 22, plumbing, 23, HVAC, 26 electrical. I know our contractors certainly get confused on where, if they're electricians, they think that, it's going to be under 26 with their electrical scope, but no, it's going to be under thermal and moisture protection. So this training how we're doing, similar for you guys, we also on projects, typically it's called out in the plans before, there has to be the installer fire stop has to be trained by the manufacturer. So that's something Brian and I do quite often. And then also there's other trainings that are called out. So the FM or UL fire stop contractor trainings, those are coming right from FM or UL. So while Hilti can take ownership of, the manufacturer training or even the manufacturer accredited fire stop specialty contractor, those are things we give out. Anything that's from FM or UL, contractors would have to go direct to them. And these are typically, from what I've seen, contractors that only do fire stop, or if I've seen drywall contractors where they have a separate fire stop division and then they will be certified through this. So any questions on our training or train the trainer type of situation? I'll go ahead and move on. So, and when you're building or when, our submittals are built, so you'll have all of your UL systems, but in the front, what's really nice is we'll provide a schedule of a system. So we'll see the example of the schedule here. So it's really just a table that's basically just laying out exactly, okay, what are my applications here? For this example, I have circular blank openings. I have single metal pipes. I have, single non-metal pipes. So any plastic, CPVC, PVC, etc., and then single cable bundles. Then next it'll give you what your F rating is. And then over on that other tab, it will show what fire stop systems are to be used. Further, if you go down in this table, there's also another tab showing for mineral wool, and it'll be like a yes or no. And then it'll say, this system uses mineral wool, this system doesn't use mineral wool. This was very helpful when there was a major stock issue with mineral wool. We're getting better now, but yeah, so really just highlighting like, really just what is in the submittal here. Brian talked a little bit about labeling before, but labeling and documentation of each fire stop application really just improves quality assurance. So it's letting building owners and then facilities of the building know, hey, this is how I treated this. There are a lot of projects that I go to that I know Brian can go to as well, where, if it's, even if it's not exactly a renovation, if it's, just if it's a healthcare building that they're servicing and they need fire stop support and they don't, they don't know exactly what was installed before. So this is, what we're trying to do here to really minimize that confusion and, really improve quality assurance. Additional considerations. So called out before that there is a section in the IBC for fire stop special inspection, so mandated for high rises in risk category of 3 and 4 buildings. So this example, high rise, occupied floor over 75 feet above lowest level of fire department access. Risk category 3 buildings are, substantial hazard to human life in event of failure. So think of, elementary school with over 250 people in, as well as any public assembly building with over 300 people. Going into risk category 4 are essential facilities. So really think of, your medical facilities, having surgery or emergency treatment, and then buildings containing highly toxic materials. So any of like our, this will go to like our civil team, our plants that are built. So this is highlighting for, compatibility. So single source manufacturer of fire stop products helps ensure consistency and compatibility. So this is a real photo from a job where these are 6 different fire stop products that are being used, 3 different manufacturers, and it's all overlapped, all intermixed. So this is a massive issue with whether it's us, whether it's 3M, STI, Medical, there's other fire stop manufacturers out there, and truthfully, they say the same things about us. The biggest thing with fire stop is this all comes down to testing. We are not tested with other manufacturers. They are not tested with us. So we can't give you that sign of approval saying this is correct because our testing centers and facilities are different. So why in the beginning of projects, Brian and I will very much urge single source manufacturer. Sure, of course, we work for Hilti, but also take that part out of it. From a fire protection standpoint, we know everything that's coming from the same testing center and the same warehouse, it's going to, be compatible and suit with each other. We can't speak to what other manufacturers have. Another call out to dissimilar material considerations. So non-combustible penetrating items shall not connect to combustible items beyond the point of fire stopping unless it can be demonstrated that the fire resistance integrity of the wall is maintained. I don't know if you guys see this a lot. I've been here a little over 2 years now, but even in my role before, this isn't something I can count on one hand the amount of time I've seen. We do have a listed solution if this is something that you guys ever come across. And if it is, you guys will get our contact information and let us know how we can support. Additionally, this is something I do see often, and I get asked almost every week, angled penetration, specifically metallic angled penetrations. So angled penetrations do not always need an engineering judgment. If there's an angled metallic penetration, it can follow the regular UL system. It just has to stay within those annular space requirements. So let's use WL 1054, for example. The minimum annular space is 0. The max is, 2 1/4. As long as at this angle that it's within that annular space, they can follow that system. So like I said, this is for bare metallic pipes this could be used for, but any combustible plastic insulated pipes, those would have to be engineering judgments. And this is right from the UL guide info. So this isn't anything Hilti specific. This is something we reference right from UL. Fire stopping around surface mounted gypsum wall patches is not code compliant. So any type of patching, and then we can see on the left, there's no fire stop around the penetrant. Any just drywall patching is just, it's wrong. It's not correct. If you see it, it's bad. And then CPVC requirements. So manufacturers of CPVC pipes determine compatibility with their products. Fire stop companies, we do not carry the responsibility since the manufacturers use all different types of formulations. So When it comes to CPVC, typically you'll have to go to that brand of CPVC and look at what their call outs are, because it's not necessarily on us. It defaults back to that manufacturer. Additionally, so at Hilti, we're gonna offer with Firestop, our traditional sealants and sprays. So, this is kind of what's thought of as, the original methods of fire protection. So this is, this correct installation is highly dependent on the installer. So typically it's a guy that's been doing it for a while. And then this, there's more required for part of this. You have to clean the area, you have to tool the fire stop if you're using any type of fire caulking, which this calls out here is often neglected. The depth of fill material varies per the installation and also the installer. I don't know if you guys have ever personally worked with mineral wool. It's not the easiest material to work with, and typically contractors, they have 1 to 2 guys that are the dedicated mineral wool guys to work with. Also, two other major points are shelf life and storage issues. So these products all have an expiration date, and a lot of them, they have to be stored within certain temperatures. And then leading into prone to waste, a lot of times when contractors are using these traditional sealants and sprays, they're factoring in some cases I've heard, at least 40% of waste. Not a very lean approach with how, the construction industry is moving, and not very productive for their work either. We have preform devices. So that middle picture is showing our fire stop cans that I mentioned before. On the left is what is called top track seal. So this is a material that saddles the drywall track. So as they're framing, the fire stop is already installed. They don't have to go back and do it. On the far right is our one of our cable devices called the modular sleeve. So this is easy, fast installation, not always having to clean the area, maybe like dusting it off, just making sure stuff isn't there. It's always being installed correctly. Anyone of any tenure can essentially do it. That's the idea. Some devices are even repenetrable, so this is just great throughout the lifetime of the building. Pre-cured, no shelf life, so you don't have to worry about anything expiring. And one of the other bigger points too is that it's easy to inspect. So, you see this as long as it's following the listing. There's no destructive testing, so this is typically going to be our ultimate solution. So at Hilti, we offer a good, better, best, not just with our tools and anchoring, but also our fire protection as well. So our standard is always going to be our caulking. And as much as I, think our preform devices are the ultimate way, it's going hand in hand with applications that are already being done. So it's not changing their work. There are some applications where caulking is just easier, and it is what it is. So these are showing different categories for through penetration, cable management, and joints and at the edge of slab. So that is all I have for you guys. If Brian wants to add anything else, my contact info is up here as well as Brian. So I directly cover LA. So if there's any support that you need on projects, or whether it's you want help looking at something, or it's a contractor that's needing some assistance, that's what Brian and I are here for. Brian, is there anything you want to add?
No, the big thing is, from time to time, Sam and I will be off or busy. So please take down my contact information as well. Hopefully this training was impactful. And if you found that it was, please take it back to your own jurisdictions, let whoever knows in charge of this. And maybe you think it'd be worth us coming in to do a training for your local jurisdiction as well, right? To help the other inspectors on your team.
Just want to thank you both, Sam and Brian, for an amazing training. I know you squeezed it pretty hard. I know you're usually about an hour and a half with your training, or even more probably, but I really appreciate you fitting us in, and great job.
Thank you.
Yeah, and I know we are over time, but if anybody does have specific questions, I'm willing to stay on and answer any questions you may have.
There was one question. What about the orange fire sprinkler pipe? As some say, there is a reaction. And I think that's CPVC. I think you kind of mentioned, stick with the parameters of the manufacturer and what the limits of the pipe are.
Yeah, I know that's a really common one. Like, for example, off the top of my head, I know that typically our CP606 isn't able to be used with CPVC. even though it may be listed on the actual listing as an option for certain sizes. With most manufacturers, it's not compatible, and that's from the chemical reactivity between the CP606 and the CPVC itself. There were actually some contractors who installed it incorrectly, right? Not checking that CPVC manufacturer's website, and then eventually they had issues with stuff like with pipe leaking and bursting because of that. So that is something that they need to confirm again with the CPVC manufacturer's database, that whichever product they're installing, us or someone else, that it is compatible.
Awesome. Thank you so much.
One other thing, Jim, I wanted to thank you guys very much for this. Is my name is Leaf. I'm with the city of Torrance. One thing I wanted to add, I know it's not part of the fire stop system, but labeling these firewalls is important too for the IT guys coming in later, or electricians or plumbers coming in and penetrating the walls, and they're not aware of what the hour rating is on that wall. And
definitely.
So one thing I think that's a real important thing, is make sure that we do have our labeling above T-bar on these, corridors and whatnot, or separation, tenant separations in our multifamily that we don't really see very often.
Yeah, definitely. Just because it helps us help you guys, right? If if we can know, exactly what we're working with, rather than, oh, I don't know, I think we'll have to check the plans, and depending on the building, plans just might not exist anymore, at least from the original detail. So yeah, it helps us help you guys. Like I said, it's a good point.
And I really like the identification of the fire stopping material, and specifically an engineering judgment if that is the case, because a lot of times you could look at an engineering judgment, and if you don't know the history behind it, you could be looking at it saying, what the heck is this? I'm not so
Right.
Information is key. I like the labeling, and definitely labeling the rating of the walls above ceiling is definitely key.
Yes.
And I believe that above ceiling is already a part of the code as a requirement. The individual systems is not. But another thing to think of, and this is, so like I said, I'm based out of San Diego. With the inspector trainings we've done down there, and what they've started doing is, if contractors can't provide their approved fire stop system or engineering judgment, inspectors are automatically failing that condition, right? Because if you don't have a listing or an engineering judgment from which to inspect, you're taking a guess just as much as the contractor is, right? We don't know what we're inspecting because there is no documentation as to what was installed. And I think that's another, and I warn contractors of that all the time when we do these trainings, is if you cannot provide the documentation of this is what was installed, this is why it was used, here's how we made sure we installed per each point in this listing, then they're at risk of you failing them without even walking, right? Because there's no point in walking and checking an install if they can't tell you what was installed. So that's another point that I've seen becoming more and more common.
It's a great point.
Where it's not on you as the inspector to figure out what system is compliant with that application. And I know sometimes contractors try to push that off on you all.
Exactly. They just try to say, it looks the same as everywhere else. It works good. And I really like the point of, the intermixing of all the different systems, and how it isn't a good idea, because a lot of times you can't even see where the old system or the new system stopped and started, or what the annular space is, because there's so much product over the opening.
Right.
So it's definitely not an easy task. It seems like it is, but it's definitely science behind it. But I really appreciate it, and thank you so much. I didn't really get time for good, bad, and the ugly, but I do have some good pictures for next time. And I hope everybody has a great day, and thanks again for joining. Hilti provides a great service, so if you have any questions or concerns, they definitely do a great job with their customer service and job visits, and checking what the situation is, and providing some guidance on applications. So thank you so much. Have a great day.
Thank you, guys.
Thank you.